Assalamualaikum. I'm Naila Asgar from MS Chemistry Batch 8. Today I'm going to explain Cradle to Cradle approach. These are the content I have prepared for this approach, which includes history, introduction, principles, cycles, product design, application, examples, benefits, hurdles, roadmap, link with SDGs, and summary. Before starting the topic, I'm going to explain about the history of humans and why we require such kind of approach in our life to survive. Round about 160,000 years ago, the first Homo sapiens started to evolve who we are now consumers. In 1804, Earth hosted 1 billion people. Now are we moving towards 8 billion with every day more than 2 like 20,000 people joining us on this planet. In modern culture, we are surrounded by commercial products that make our life pleasurable and more convenient. So imagine there are 8 billion of us. This means mass production, being able to produce all these products, means we use resources, but there is a problem. During all these years, we kept use in these resources without thinking of reusing them. This has led to the potential problem, and the time will come when there is a resource scarcity and other problems, which is waste. Now, I'm going to start the topic, which is the traditional industrial models follows the take make dispose system. Resources are extracted, used to make products, and ultimately discarded as waste. This result in resource depletion, population, climate change, landscape, etc. In order to overcome these crises and ensuring the future generation has access to the same resources as present, the concept of sustainability developed, which include the development of product in a way which is beneficial to current population and ensure the long-term health of planet and its resources. For sustainable production, circular economy has been developed in contrast to circular economy, which involves consume and throw away. Circular economy was a model of production and consumption which involves sharing, leasing, reusing, repairing, refurbishing, and recycling existing products and products as well as possible. In this way, the life cycle of the product is enhanced. This is why we call this model cradle to cradle, which is emerged as an ideal for product life cycle. Now I'm going towards the introduction of Cradle to Cradle. Cradle to Cradle is a design framework focused on creating system where waste is eliminated, products are continuously reused, unlike recycling, which promotes complete regeneration. It is developed by architect William and chemist Michael in early 20s. It is a philosophy inspired from nature, which works on the principle upcycle, which includes waste from one person become the food from another for another. And the C2C approach mimics this principle in design and manufacturing. Now we have to know about LCA. Before diving into cradle to cradle, we first need to understand this that what is the life cycle of the product. Just like people, product go through survival like cycle stages, which include raw material extraction, production, processing, transportation, usage, retailing, and then disposal, also known as grave. There are three main product life cycles models which can implement in LCA, which is cradle to cradle, cradle to gate, and cradle to grave. First is cradle to gate. Cradle to gate also assesses on product's footprint until it leaves the factory gate before it is transported to the consumer. And the second is cradle to grave, which include all five life cycles in your footprint measurement. It shows a full footprint from start to end. And the third is cradle to cradle is a variation to cradle to grave, but exchange wastage with a recycling upcycling process that make it usable for another product, essentially closing the loop. Now There are the five main pillars, like principle of the cradle to cradle approach, which are as follows. First of all is material health. This principle ensures that material is safe for humans and environment. It involves interventing, assessing, optimizing all chemicals in the product to eliminate toxin hazards, creating positive impact on health in of our ecosystem. And the second one is product circularity. This principle is focuses on designing products and system to keep in material circulation. It requires designing, disassembling, recycling, compositing, ensuring that material become nutrient for new product in either technical and biological cycle. The third one is clean air and climate protection. This pillar promotes manufacturing that is powered by renewable energy. It aims to reduce, eliminate greenhouse gas emission and other pollutants, protecting air quality and taking urgent action to address climate change. And the fourth one is oil and soil stewardship. This principle treats water as a precious resource to be managed responsibly. It requires companies to treat industrial wastewater to a standard return to the local environment while also protecting and enriching the soil health. Fifth one is the principle ensures that the company is committed to upholding human rights and applying fair and equitable business practices. It involves change to protect the well-being of all human communities involved in the product creation, which is called social fairness. Now, cradle to cradle approach involves different kind of cycles, which is biological cycle and technical cycle. Technical cycle is the most effective way of retaining the value of the product is to maintain and reuse them. It takes the example of the phone. It is far more valuable as a phone than a pile of components and material. The first step in the technical cycle is to focus on keeping the product whole to retain their maximum possible values. Eventually, when the product was no longer be used, its component can be remanufactured. What a part that cannot be remanufactured can be broken down into the constituent material and recycled. While recycling the optional is the option of last resort because it means the embedded value in product and components are lost. It is vitally important as the final step that allows the material to stay in the economy and not to end as a waste. The second cycle is biological cycle. In biological cycle, biodegradable materials which cannot be reused, like some food byproducts, which can be circulated back to the economy in the biological cycle by compositing or anaerobically digesting organic material. Valuable nutrients such as nitrogen, phosphorus, potassium, and micronutrients can be used to help regenerate the land so we can grow more food and renewable materials like cotton and food. Some products like cotton, clothing, or wood furniture can be circulated through both the technical and biological cycles. They can be maintained, reused, repaired, and sometimes even recycled, but eventually they can be returned to the biological cycle from which they came. Composite or anaerobic digestion, they can feed the soil to grow new cotton or wood. In order to product to successfully be circulated in either the biological and technical cycle, it is essential that they have been designed with their eventual circulation in mind, and this is the key of success. Now, there is a product design for cradle to cradle approach, which includes reusing on the product or product level. Many products reach the end of their life because one or two component materials fail, and other products are still good as new. Instead of discarding them, put them to good use. Reuse the whole product in a new product. Upcycling is the same process for reusing old material, but instead of just reusing a material, it is used to create a product component that is more far valuable or of higher quality than its original forms. Reuse subcomponents to make new components. Reuse the broken components after repairing them. To make this possible, design your product in a modular way with the goal of easy component use in mind. You can also reuse the whole product according to these two ways: upcycling and refurbishing. Upcycling involves the reuse of whole product or material to create a product with higher quality or value, and refurbishing involves the reuse of the whole product by replacing broken parts and then sell the broke product again. And the second way is recycling at the resource level. Recycling means transferring component back to their raw material to be used again. In this way, you can't reuse or repair components. You can recycle the material. Sometimes 100% of the material can be recovered without any quality loss. Like thinking of skill, unfortunately, many materials lose quality when recycled. This is why downcycling. This is what called downcycling. This is what we want in that circular economy. It is granularly kicks the product out of the economic loop. Therefore, aims to choose to reuse over recycling where you can. Tips: there are some tips I'm going to share while designing the component for recyclability. Make it easy to separate components into the foundational materials. Often makes the recycling process less impactful. Keep material pure. The fewer resources type you mix up, the better you can be recycled. Make components that are bound to break from 100% recyclable material. And now there are the lot of applications of cradle to cradle approach. Now, first of all, I'm going to explain the application of cradle to cradle approach in the textile industry. Textile industry focuses on creating sustainable circular systems, which is only possible by using cradle to cradle approach, where materials are continuously recycled and safely returned to their environment without generating waste. Here how it is implied. First of all, it material selection and design, and then circular production process matters. Material selection involves the use of organic, biodegradable, and recyclable fibers. For example, organic cotton, hemp, aloe vera, recycled polyester, etc. Elimination of toxic waste for finishing and treatments. For example, azo dye, wet dyes, formaldehydes, finishing agents, surfacing agents is also done. Modular design, designing garments for the easy disassembly. For example, separable zippers, buttons, and threads for recycling. And second one is circular production process, implementing water-less dyeing, for example, carbon dioxide dyeing and wastewater treatment, using solar, wind, biogas to power textile manufacturing, zero waste manufacturing, like cutting techniques that minimize fabric waste, for example, 3D knitting. And the second application is in buildings and architecture. Cradle to cradle approach aims to eliminate waste and circular economy for building materials, promoting reuse, repurposing, and recycling. Example: Ford River Road Complex, like planting vegetation on the roof to retain and cleanse rainwater, moderating internal temperature, and saving on mechanical treatment facilities. Second is Herman Miller Aron chair, designed for disassembly, recycling, demonstrating the principle of cradle to cradle in furniture manufacturing. And the third is H carpets, offers cradle to cradle certified carpets that are designed for material health, reutilization, and other sustainable practices. In packaging, cradle to cradle approach is also employed, as the picture shows in previous page. Some shampoo bottles are prepared from the ocean plastic, which is biodegradable, recyclable, and reuse of packaging material. Now, cradle to cradle approach examples which are in actions are as follows. The principle of cradle to cradle are not just theoretical. Industrial leaders across the global are improving the model variability and success. These companies are transforming their sector by creating innovative product designed for circularity, from textile and building materials to consumer goods, which includes Prabhita in Syntex, pioneers to cradle certified textiles committed to regenerative farming and circular fashion. Second, a Re-Up brand in Italy, the first textile brand to achieve C2C certified circularity for all product, demonstrating full system design circular design. Third is Marmara Hemp, upgraded to Cradle certified material health certified platinum milestone in sustainable textile. And fourth one in Hermans Miller, which is a well-known international brand known for its Cradle certified furnitures like the Aeron chair built with modular recyclable parts for easy material recovery. And the other one are also written, which is Cradle ALP Project Metal Cleaning Products, L'Oreal, which is the most known brand, which is actively expanding its profitability of Cradle to Cradle certified products, raising the bar of sustainability in the beauty industry. There are trade-off benefits which we can get after following adopting cradle-to-cradle approaches. Adopting cradle-to-cradle approach is not just for environmental decision. It's a strategic business moves that create value across environmental, economic, and social domains. The holistic approach fosters resilience, drives innovation, and enhances brand reputation in the world that increasingly values true sustainability. And there are the benefits like environment stewardship, economic value creation, positive social impact. A significant environment stewardship significantly reduce landfill waste, conserve virgin resources, and lower greenhouse gas emission through circular design and renewable energy integration. And the second is economic value creation, unlock cost saving through material economy, creates new revenue streams from recycling material and boost brand value among eco-conscious consumers. And third is positive social impact, which improves human health by eliminating toxic chemicals from products and promote fair labor practice and community engagement across the entire supply chain. They are very there are a lot of hurdles we have to overcome in order to adopting circular economy like cradle to cradle approach. Trans from a linear to circular model is a transformating process that presents survival challenges. Addressing these hurdles requires strategic investments, deep collaboration, and a fundamental shift in mindset. The first hurdle we have to overcome is material complexity and product design. The challenges we have to face is products are often made from composite material that are hard to separate and recycle. Lack of design for disassembly and reuse. The solution to these problems are adopt modular design and cradle-to-cradle certified material. Use single material components or clear labeled separable materials. Implement digital product passports to track materials throughout the life cycle. And the second hurdle is high initial cost and economic barriers, which challenges circular solutions often requires upfront investment in redesign information and supply chains. Difficulty quantifying long-term savings and non-monetary benefits. The solution to this problem is to apply life cycle costing (LCC) to demonstrate long-term economic value, leverage green financing, public subsidies, and circular economic incentives, promote product as a service bus models to generate recurring revenue and retain product ownership. And third point is technological and information infrastructure gaps, which challenges include limited access to advanced recycling, repair, remanufacturing technologies for fragmented waste collections and sorting system. The solution to this problem is to invest in R&D for material recovery technologies. For example, chemical recycling, develop regional circular hubs, and industrial symbiosis platforms, encourage public-private partnerships to scale infrastructure, for example, lack of supply chain transparency, challenge difficulty tracking material flow, especially in global and multi-tier supply chains. The solution to this problem is use blockchain and digital tracking tools for transparency, establish collaborative platforms for circulatory procurements. The fifth point is policy and regulatory gaps, which challenges linear systems are still supported by outdated regulation and subsides, lack of standardization for circular metrics and certification. The solution to this problem is to advocate the extend producer responsibility and mandate take-back schemes, align business models with EU Green Deal, Circular Economy Plan, Action, and national C2C policies, encourage public procurement that prioritize circular products. And the sixth point is consumer awareness and engagement, which challenges consumers may prefer low-cost disposable and products and be unaware of circular options. And the solution to this is to conduct sustainability labeling and educational campaigns, offer incentive for returning products, for example, deposits and loyalty points, design product with a visible sustainability value and emotional durability. Seventh point is business model inertia, which challenges companies resist change due to fear of risk, loss of control, and uncertain ROI. Solution to this problem is to start with pilot product projects to test circular models, demonstrate value through case studies and industry benchmarks, shift KPIs to include material efficiency, reuse rates, and product lifespan. And the eighth point to be noted is collaboration and systematic integration, which challenges circularity, requires multi-stakeholders coordinations, which is often lacking. The solution to this problem is to promote cross-sector symbiosis, using one industry's waste to another, inputs, engage in education and trainings across supply chain. There is a roadmap for cradle to cradle implementation. Adopting cradle to cradle principle is a strategic journey. This roadmap outlines the key phase for an organization looking to embrace circular designs, moving from initial assessments to continuous improvement. Industry leadership in sustainability. First point to be noted is commit and assess. Green leadership buy-in and conduct a full material health assessment of product process. Secondary design for circularity. Engineers for assembly prioritize safe materials and integrate renewable energy sources. And third point is to build closed loop systems, implement take back products, reboost recycling, and effective recycling processes. Fourth point is collaborate and partners, engage suppliers, customers, and stakeholders to build a collaborative circular ecosystem effort. Fifth point is certified and improve. Use Cradle to Cradle certified standards as a framework for continuous optimization and public validation. Now, most important topic, which is a link of cradle to cradle approach, is with SDGs. I am going to explain. The cradle to cradle approach is deeply aligned with United Nations sustainability goals by promoting regenerative design, eliminating waste, using safe materials, and closing resource loops. Cradle to cradle support survival SDGs both directly and indirectly. It links with SDGs number 3, good health and well-being. Cradle to Cradle ensure the use of non-toxic safe material in product and building, which reduce exposure to hazards, chemicals in air, water, and consumers would promote healthier indoor environments and product, for example, textile and furnitures. And it links with SDG number 6, 7, 8, which is clean water and sanitization, which is water stewardship is a core C2C principle. Design aims to water living a factory to be cleaner than when it returns, encourage closed loop water use and elimination pollutant in water waste. And the seventh SDGs is the affordable and clean energy. Cradle to Cradle promotes the use of renewable energy in manufacturing and product use, which reduce the dependency on fossil fuels, sport energy, positive buildings, and clean production systems. And the eighth SDGs, which is linked with the Cradle to Cradle, is decent work and economic growth. Cradle to Cradle it drives innovation and green jobs. It stimulates growth in sectors where recycling, renewable energy, sustainable material, and green designs encourage long-term economic resilience through circular business models. And with SDGs number 9, industry innovation and infrastructure, C2C refers uh, fosters innovations and sustainable industrial practices. It encourages R&D in green chemistry, smart materials, rich and regenerating systems, promote resilient infrastructure through durable, recyclable, and adaptable designs. It and SDGs number 11, sustainable cities and communities, cradle to cradle in architecture, urban planning creates safer, healthier, and circular cities, promotes building as material banks for reuse and assembly, encourage biodiversity, clean energy, and cradle-to-cradle certified construction principles. With SDGs number 12, responsible consumption and production. This is the most directly aligned SDGs with cradle-to-cradle, which focuses on designing out waste and pollution, encourage circularity across product life cycle from design to reuse, advocates for safe material cycles and sustainable packaging and circular procurements. And with SDGs number 13, which is climate actions, C2C reduce greenhouse gas emission through energy efficiency, renewable energy use, and material recovery, encourages carbon neutral and carbon positive products and buildings. SDGs number 14, 15, and 17 also linked with Cradle to Cradle, which is life below water, life on land, and partnership for goals. Cradle to Cradle protects ecosystem by preventing the release of toxic substance and reducing pollutions, reduce marine plastics, and chemical runoff, support biodiversity through sustainable materials, sporting and habitat conscious design, and Cradle to Cradle encourage collaborative among designers, manufacturers, policy makers, and consumers. It also promotes knowledge sharing through certification frameworks and international networks. And the summary of this whole topic is that the cradle to cradle approach is a forward thinking and regenerative design philosophy aimed to creating products, process, and systems that illuminate nature's circular model where waste is eliminated, the material continuously flow in safe, healthy cycle. Unlike the conventional cradle to grave model that ends with landfills and incineration, cradle to cradle promotes the idea that our materials can either safely return to the environment as biological nutrient and perpetually reused as technical nutrients in industrial systems. This approach is grounded in several core principles, eliminating waste through intelligent design, using non-toxic and safe materials, relying on renewable energy, steward water responsibility, promote biological and cultural diversity. It encourages designers and manufacturers to rethink products not just for functions but also for the entire life cycle, ensuring material can be recovered and reused without regarding in quality. By designing for assembly and recyclability, cradle to cradle sport, a circular economy where products are not simply less harmful but actively beneficial to people and the environment. It finds application across industry for sustainable product and packaging design to green architecture and urban planning, serving as both a design framework and a certification standard that guides innovation and towards a more sustainable future. Thank you for listening my presentation Cradle to Cradle approach.